So I'd like to quickly go over our real number system, and just in a few short minutes, so it is an overview. The first kinds of numbers that we're going to deal with are the most basic numbers that you can count on your fingers, so like 1, 2, 3, 4, all the way up to infinity if you had enough fingers. So let's call those the natural numbers. So natural numbers start with 1, then go to 2, then to 3, then to 4, and go up in these whole number increments up to infinity, a positive infinity. So those are natural numbers. Then let's add to this. Let's say that we want to expand it to include 0. So 0 is not a natural number, but if we want to include it in a set of numbers like this that goes up to infinity, let's call them whole numbers. So whole numbers are numbers that include all of the natural numbers as well as 0. Let's keep expanding. So let's say we want to do all the whole numbers and their opposites. So that would be like -4, -3, -2, -1. The negative of 0 is just 0 again, and then 1, 2, 3, 4. So do you see we're going up to positive infinity and down to negative infinity? We're going to call these integers. Integers. So integer means indivisible, which means that we're not talking about fractions or decimals yet. Do you notice that everything are kind of like whole kind of numbers or their opposites? So we're not dividing anything, no like 2/3 or 4/10. We're not doing that. So these are integers. So by the way, every time we expand out, these expansion sets, like integers, not only includes what it adds, like in this case negative numbers, but it includes everything else that we started from that's on the inside of these circles. That's why this integer circle is including the circles that are smaller inside it, okay? So integers include whole numbers, include natural numbers. So 4 has a lot of identities. 4 has an identity as a natural number, it has an identity as a whole number, and it has an identity as an integer. However, 0 only has an identity as a whole number and an integer. 0 is not a natural number. -3, for instance, is only an integer. It doesn't count as a whole number or a natural number. So some numbers have a lot of different hats that they wear, but some numbers can only take the most outer part of the division of, or the categorization of numbers that we're doing. Let's broaden it further out. So now, remember, integers are indivisible, so we are not dealing with decimals yet. Now let's deal with some decimals like 0.4 or 2/3 or 0.555 ... meaning repeating. So these repeating decimals, these terminating decimals, for a decimal to terminate, it means it ends. Just like a bus route terminates at the bus terminal, meaning it stops, that's what a terminating decimal means. It does not go on forever, it stops at some point. And these numbers over here, like 0.555, that goes on forever, these ellipses, these dots, show that it goes on forever, but because I have 5 being repeated over and over and over again, it shows that this is a repeating decimal. So repeating decimals, as well as terminating decimals, as well as fractions, are considered all rational numbers. Rational numbers. The word ratio is inside rational, because 4/10 can be written as a ratio. 2/3 is already written as a ratio, and 0.555 on forever can be written as a ratio. If you're curious, 0.555 repeating forever is 5/9. And if you're curious as to what 0.4 is, if you can say it, you can write it as a fraction. So 0.4, 4/10 could be written as 4/10. So do you see that a ratio is embedded in all of these forms, as well as all the numbers that have come before it. So all of these numbers can be written as ratios too. A way that you write a natural number as a ratio is you just put it over 1. So 4 could be rewritten as 4 over 1. Any number over 1 is just itself again. Same with whole numbers. Even 0 over 1, that's just 0. And integers could be rewritten, let's say -4, put that over 1, and you now are representing -4 as a ratio. So all the numbers in here are also rational, as well as these added on numbers. And this completes 1/2 of our real number system. The other half of our number system are called irrational numbers. Okay? They are outside of this. So we're gonna make a box here. We're gonna make a box here. And this is completely separate than anything over here. Irrational numbers are decimals that never end and never repeat. Okay, so for instance, pi is 3.14159 ... It never ends, and you didn't hear any patterns in that. So pi is irrational, meaning that it can never be written as a ratio. There's no way we can turn pi into a ratio, okay, like we can with these guys, or we can't turn pi into a fraction. It can be approximated as a fraction, like 22/7, but that's only a rational approximation. It's not actually pi. Also, the square root of non-perfect squares. Okay, so 2 is not a perfect square. 10 is not a perfect square. So the square roots of these will not be rational numbers. They'll be irrational numbers. The square root of perfect squares are rational. Square root of 9 is 3. The square root of 16 is 4. So those are nice rational numbers because they're perfect squares. 16 is a perfect square. 25 is a perfect square. Square root of 25 is 5. But the square root of non-perfect squares, 2, 10, any number that you can think of that's not a perfect square will come up with an irrational number. These are just some examples of irrational numbers, and there's infinite amount of irrational numbers. But I just wanted to let you know that when you add in all of these rational numbers plus all these irrational numbers, we come up with a complete real number system. Oh, I wrote that off so you can't see it. But anyway, these two put together are known as the real number system. And I'll give you some questions on trying to categorize these different numbers within the real number system.